Finding the domains of rational functions and simplifying rational expressions. If p and q are polynomials, where q is non-zero, we call the ratio p divided by q a rational expression. Rational functions. Definition. A rational function is a function whose equation can be put into the form f of x equals p of x divided by q of x, where p of x and q of x are polynomials and q of x is non-zero. In this example, evaluate f of x equals 3x plus 1 divided by x squared minus 2x plus 5 at the indicated value, f of 3. Substituting, we get 3 times 3 plus 1 divided by 3 squared minus 2 times 3 plus 5. Calculating, to find our numerator, 3 times 3 plus 1 gives us 10. For our denominator, 3 squared minus 2 times 3 plus 5 gives us 8. So that equals 10 divided by 8, which equals 5 over 4. So f of 3 equals 5 divided by 4. In this example, we still want to use f of x, but this time evaluate f of negative 2. So that gives us 3 times negative 2 plus 1 divided by negative 2 squared minus 2 times negative 2 plus 5. Calculating, for the numerator, 3 times negative 2 plus 1 gives us negative 5. For the denominator, since our 2 is negative, we want to use parentheses. The negative 2, close parenthesis, squared, minus 2 times negative 2 plus 5, which gives us 13. That equals negative 5 divided by 13. This can't be reduced, so f of negative 2 equals negative 5 over 13. Rational functions. Domain of a rational function. The domain of a rational function, f of x equals p of x divided by q of x, is the set of real numbers except for those that, when substituted for x, give q of x equals 0. Excluded value. Definition. A number is an excluded value of a rational expression if substituting the number into the expression leads to a division by 0. In this example, find the domain of the function f of x equals 7 divided by, in our denominator, x minus 4. Before we discuss the domain, let's look at the graph of this function. To graph our function, we need to go to y equals, then we want to type in 7 divided by, and we need to use parentheses because x minus 4 is the entire denominator. Close parentheses, and now we want to go to zoom, standard 6. So looking at our graph, you'll notice that it goes down from left to right, then it starts at the top and goes down from left to right. So to see what happens here, we want to go to our table. So second and graph will get us to our table. And you'll notice that at 4, it gives an error. 4 is what's called the asymptote, and that's where it cannot be graphed. The reason it can't be graphed is if we take f of 4, substitute, I have 7 over 4 minus 4, which gives me 7 over 0, which is undefined. So that's why there was an error when x equals 4. Anytime you're dealing with a rational function, there will be one or two values that will not work and give us 0 in our denominator. One way to figure this out without graphing is to take your denominator, x minus 4, and set it equal to 0, then solve for x. We get x equals 4, which was the number that gave us the error on our calculator. So how this applies to our domain is that our domain will be all real numbers except 4. In this example, find the domain of the function f of x equals x plus 5 divided by x squared minus x minus 20. One of the ways that we can figure out our domain is by setting our denominator equal to 0. X squared minus x minus 20 equals 0. I need two factors of negative 20 that add to be a negative 1. X minus 5, x plus 4 equals 0. X minus 5 equals 0, meaning x equals 5. X plus 4 equals 0, which means x equals negative 4. So these should be the two values that will give us 0 in our denominator. Looking at the graph, y equals parenthesis x plus 5, close parenthesis, divided by parenthesis x squared minus x minus 20, close parenthesis. If we don't use the parenthesis, the calculator would take the 5 and divide it by x squared. Graphing, you can see that we have two breaks in our graph. So we do have two asymptotes. Second graph to get to our table, we have an error for x equals 5, arrowing up. I also have an error at x equals negative 4, which were the two numbers that we found when we set it equal to 0 and solved. Our domain is all real numbers except 5 and negative 4. Simplifying rational expressions. To simplify a rational expression, 1. Factor the numerator and the denominator. 2. Use the property a times b divided by a times c equals a divided by a times b divided by c equals 1 times b divided by c equals b divided by c, where a and c are non-zero, so the expression is in lowest terms. Connection between vertical asymptotes and domains. Vertical asymptotes and domains of rational functions. If the graph of a rational function f has a vertical asymptote k, then k is not in the domain of f. If k is not in the domain of a rational function g, then x equals k may or may not be a vertical asymptote of the graph g. In this example, we want to simplify the expression f of x equals 20x to the 7th divided by 15x to the 4th. I know that 20 and 15 share a 5, so I can look at 20 as 5 times 4, and I can look at 15 as 5 times 3. X to the 7th and x to the 4th share x to the 4th. So x to the 7th can be written as x to the 4th times x to the 3rd. And then I just write x to the 4th as itself. Then I can cancel out anything that gives me a 1. So my final answer is 4x to the 3rd over 3. Or since my x to the 3rd is in the numerator, 4/3 x to the 3rd. In this example, simplify the expression f of x equals, in the numerator, 4x minus 28, in the denominator, 5x minus 35. Looking at 4x minus 28, 4 and 28 share a 4. If 4 is my greatest common factor, then I'm left with x minus 7. In my denominator, 5 and 35 share a 5. If 5 is my greatest common factor, then I'm left with x minus 7. In order to cancel a parenthesis, it has to be exactly the same. I have x minus 7 in the numerator, x minus 7 in the denominator, so they can cancel. My final answer is 4/5. In this example, simplify the expression f of x equals x squared plus 7x plus 10 divided by x squared minus 7x minus 18. This isn't a problem that I can just start canceling. Because of the plus and the minus signs, I must factor first. So that equals, I need two factors of 10 that add to be 7. So my numerator is x plus 5, x plus 2. For my denominator, I need two factors of 18 that multiply to be a negative 18, but add to be a negative 7. So that will be x minus 9 and x plus 2. The x plus 2's can cancel, so my final answer is x plus 5 over x minus 9. It's always a good idea to check to see what your excluded values are. For x minus 9, the excluded value would be 9. For x plus 2, the excluded value would give us negative 2. You can check this on the graph. On our calculator, go to y equals, parenthesis, start our numerator, x squared plus 7x plus 10, close parenthesis, divide, open parenthesis for our denominator, x squared minus 7x minus 18, close our parenthesis. Go to zoom, and let's arrow down to zoom fit. Enter. It looks like we have one asymptote. Let's go to our table, second graph, and notice that we have an error at negative 2. And an error at 9. However, since the x plus 2's canceled, we only have an asymptote at x equals 9. And our excluded values are 9 and negative 2. In this example, simplify the expression f of x equals x squared minus 49 divided by x squared minus 14x plus 49. First thing we want to do is factor. So equals, our numerator factors into x plus 7, x minus 7. Our denominator, x squared minus 14x plus 49, factors into x minus 7 times x minus 7. Our x minus 7's cancel, which means this reduces to x plus 7 divided by x minus 7. Checking for our excluded values, since my denominator was x minus 7 times x minus 7, I only have to consider x minus 7. If x minus 7 equals 0, then x equals 7. So our excluded value will be 7. Checking this on our calculator, go to y equals, parenthesis, x squared minus 49, close parenthesis, divided by, open parenthesis, x squared minus 14x plus 49, close parenthesis. Go to zoom, 6 for standard. Second graph gets us to our table, and under 7, I have error. So 7 is our asymptote and our excluded value. In this example, simplify the expression f of x equals x minus 5 divided by 5 minus x. In our numerator, we have a positive x and a negative 5. In our denominator, we have a positive 5 and a negative x. Since I have a positive 5 and a negative x and I need the opposite, I can factor out a negative 1, which would leave me with a negative 5 plus x, which I can rewrite as negative 1 times x minus 5. And now I can more easily tell that I have a common factor with the numerator. So this equals x minus 5 divided by negative 1 times x minus 5. The x minus 5's cancel, which means I have 1 over negative 1, which is negative 1. To see if I have an excluded value, 5 minus x equals 0. Add x to both sides, and 5 equals x. So our excluded value is 5. So on the calculator, we want to go to y equals parenthesis x minus 5 close parenthesis divided by parenthesis 5 minus x close parenthesis. Zoom, and we want to go with 6 standard. Notice we have a straight line through negative 1, but right here we have a split. Going to our table, second graph, you'll notice where we had that split, 5, that's our error. So our excluded value is 5. Find the domains of rational functions in simplifying rational expressions. A rational function is any function that is written in the format f of x equals p of x divided by q of x. To simplify a rational expression, you have to have the same thing in the numerator and the denominator, which means we can use our property a times b divided by a times c, where we cancel the a, leaving b divided by c. We also need to be on the lookout for excluded values, and those are any values that when we substitute that value in for x, we get an undefined answer.